Hey everyone, welcome back to yet another fun and exciting Algebra 2 class. Today we are going to be in chapter number 2, lesson number 6. This is on page 107, 106, lesson 2.6, rational equations. The word rational in algebra doesn't really mean exactly what, like a rational number is just any number, like 6 is a rational number. But here in algebra, when we say rational equations, we're not talking about just regular equations. We're talking about fractional equations. So when you hear the word rational, I want you to think about fractions, fraction equations. So we've kind of already talked about this, and we've talked about how to eliminate the fraction, and that is multiplying by the LCD. But sometimes when we get into more complex fractions, it's a little bit more challenging to do that. So finding the LCD, multiplying by the LCD, things like that. But there is another method, and this is on page 106. There is another method that I want to start with today that we haven't really talked about too much yet. And that's called the proportion method, or we could call it the cross multiplication method. So maybe you remember, if you look down here at the screen, maybe you remember back in baby math when you learned how to do things like 3 over 4 equals, x or blank over 6. And now this one is a little bit challenging because we can't say, okay, 4 times what gives me 6? We don't know. And so we learned that we had to cross multiply. And we would come up with an equation from that. We would come up with 4x equals 3 times 6. And we would go ahead and 4x equals 18. Divide by 4, and we get x equals 18 over 4. We could reduce that out a little bit. And what do we get? 9 over 2. So 9 over 2 would be our answer. Well, we've been doing that for several years now. That idea of cross multiplication shouldn't be too complicated for you. That's called a proportion. And we've been dealing in those, and you've practiced those many times. Now, what we can do is we can add it to algebra now. And so what we'll do is we'll take this and we'll multiply it, and it will equal this, because the means always equal the extremes. And this is something that we've learned. So let's start with this one, and let's just like distribute. Let's kind of set it up so it's distributing. So 3 times x minus 3. That's this one right here. Okay, that's this guy. 3 times x minus 3 equals, and then we'll do this one, 2 times x plus 4. And it doesn't matter what order you put them in, you could switch it and you're going to get the same thing because of the equal sign, because of the commutative property with multiplication. If you turn the things, it doesn't really matter. But the key is it has to be cross. You can't do this. That's not going to work. You can't do 2 times x minus 3. You have to do it cross. All right, so here we go. And what we're going to want to do is go ahead and distribute that. So 3x minus 9 equals 2x plus 8. We'll go ahead and move this over here. Minus 2x minus 2x. We'll go ahead and move this over here. Plus 9 plus 9. And so this is going to cancel. This is going to cancel. And this is going to give us 3 minus 2 is x equals, and that would be 17, and that would be our answer right there. Okay, so that's not too bad. Like I said, we've done that a while, and you should be able to handle that. Now, that is the proportion method. If you look on page 107 of your book, you're going to see a secondary method, and we've already practiced this method as well in Algebra 1, but this is called the LCD method, least common denominator. And so this method, in my opinion, on these ones, it's a little bit more complicated, but sometimes it's the only method that works. The proportion method won't work. It's just the proportion method gets too complicated. So the LCD is easier. So sometimes you're going to find the proportion method's easier. Sometimes you're going to find the LCD method is easier. In this case, I think the proportion method is easier. You can make your own decision on that in just a second. But what is the LCD? The LCD is, well, there's nothing common. So the LCD is 3 times x plus 4. And so what I want to do now is I want to multiply everything times 3 times x plus 4 over 1, since we're dealing with fractions. Okay. And so what happens here is I'm going to get this one to cancel with this one. So we are left with 3 times x minus 3 equals, what's going to happen here is I'm going to get this to cancel with this. And so we're going to end up with 2 times x plus 4. Now I want you to see something, and this is quite interesting. Okay? Take a look at this, because what happened right here is when we did that, what did we get? 3 times x minus 3 and 2 times x plus 4. Well, we are right back to where we started from. So on this one, there's no real difference. It's just kind of the way that it works out. Some of them, there will be a difference, okay? But in this one, there's no real difference. And so we'll go back down here, do the same thing over again, and we end up with x equals 17 again. Same thing. But you need to know both of those. You need to know both of those methods, because some of these you're not going to be able to easily find the LCD. And some of them it'll make more sense to do the proportion. Some of them the proportion will be very complicated, so it's going to make more sense to do the LCD. And so it's just kind of it's a feel. It's whichever one you feel like is going to be best for that problem itself. All right, so let's take this one for example. And in this case, I could use either method here, but let's do the proportion, okay? So let's do this and this. So I have 3 times x, let me get rid of this, sorry, can't see what I wrote, x minus 3 equals 2x times x minus 4. All right, now something interesting is going to happen here. This one comes out fine, 3x minus 9 equals, well, look what happens here. I get 8x squared minus 8x. Well, I'm sorry, I wrote that wrong. It's 2x squared minus 8x. Well, we have a little bit of a problem. I mean, I don't think it's a problem. It's just a little bit more complicated maybe than what we've been dealing with. And here's the complication. The complication is this right here, this squared term right here. Okay. Well, what's going to happen right here is this is actually going to turn into a quadratic equation. What do you mean? Here's what I mean. Start solving it. Start moving things to one side. And you say, well, but I have an x squared. It's okay. So just kind of move this over here, so minus 3x, and move this over here, plus 9. And these two things are going to cancel, and you're going to get 0 equals 2x squared minus 11x plus 9. And if you'll look, we now have a quadratic equation in standard form. Now, if you want to, if this makes you happy, you can change the 0 and put it over there. So you get 2x squared minus 11x plus 9 equals 0. It's fine. Now, what I would do is I would go ahead and I would factor this out. Now, you could solve it. Remember, we learned 4 different ways to solve these. We can factor. We can complete the square. We can square root both sides, extract the root, or we can use the quadratic formula. Those are our 4 different ways to solve this. I think factoring this is probably the easiest way. So my factors of this are just going to be 2 and 1. So one of these is going to be a 2x and one of these is going to be an x. And they're both going to be set equal to 0, remember, because we're solving equations here. And then we'd have a 9. 1 and 9 or 3 and 3. So those are our 2 options. I'm going to take a little bit of a shortcut just to keep the video a little bit shorter because I know which one it is. And maybe if you're looking in the book, looking at the example, you know which one it is too. So let's do the 1 and 9. And so our signs are going to be plus and minus here. Or excuse me, are going to be minus and minus because we have a plus here and a minus here. So that means minus, minus. And so we'll go 9 and 1. All right. And if we FOIL this, we will end up with the thing. Okay, that is the correct factoring of that. So now what we're going to do is we're going to solve these separately. So 2x minus 9 equals 0 and x minus 1 equals 0. So add 1 to both sides. We'll solve this one first since it's easier. We get x equals 1. So there's one of your answers. The other answer would be, let's send this over here by adding 9 to both sides. 2x equals 9, divide by 2, divide by 2. X equals 9 over 2. And so those are our two answers. Now, it's quite a bit of stuff that just happened right there. It seems like it should be easier than that, right? When you're looking at this, it seems like, okay, that should be a lot easier, but look at what happens. It turns into a quadratic, and then we have to factor the quadratic, or what are some other things that we could do? We could have completed the square. We could have done the formula, used the quadratic formula. Any way that we did that, we would have gotten the same answer. So it's your choice. I thought factoring was the easiest choice there. Maybe you thought another method was, and that's fine. If you think another method's easier, you can use that. All right, so then I got my answers, and I can check my answers. I can plug those in. I'm not going to take the time to check those, but if you did check those, you would get that. You would get that it is the correct answer. Every once in a while. Now, I say that I'm not going to check it, and I should have checked it, but I'm not going to check it. But let's say that when I check it, don't forget this, and we've talked about it a lot. Let's say that one of the answers does not come out correct. One of the answers comes out wrong. Don't forget that you can have extraneous solutions. Okay, and an extraneous solution is a solution that does not check. There's something wrong with it. It comes out, that's the answer. Like you could keep doing the problem over and over, and that's the answer. But when you plug it back in, it doesn't check. And that's an extraneous solution. So sometimes you're going to have to mark these on your quizzes or tests. You're going to have to mark these extraneous because that means that they don't check. They don't work in the checking of the problem. The answer works, the check doesn't work. Okay? And so that means that it's actually not a real answer. It's extraneous. All right. So any questions on that? Rewind the video, watch it again. Hopefully you learned something today. We'll see you later. Bye.